Welcome back to the Explainer. Today, we're diving deep into the NCP-MCI 7.5 exam, specifically focusing on subtopic 14.5, proactive monitoring and alerting. So, if you're an infrastructure admin gearing up for the Nutanix Certified Professional Multi-Cloud Infrastructure certification, you are in exactly the right place. We're zeroing in on one highly testable objective today. We'll be unpacking the Alerts and Events Monitor, exploring how anomaly detection actually works under the hood, and showing you exactly how to navigate the specific interface elements that the exam absolutely loves to test you on. And just to set the stage, we are keeping our baseline firmly on AOS 7.5.5, AHV 11.0, and Prism Central 7.5.
Okay, let's dive right into this 5-part playbook. We'll look at why proactive monitoring matters, do a walkthrough of alerts and events, take a deep dive into anomaly detection, point out some common exam traps, and finally, wrap up with the key facts you've got to memorize.
Section 1, Why Proactive Monitoring Matters. To really get this, we first need to understand the baseline context of your Acropolis operating system, or AOS, and the Acropolis hypervisor, AHV, and how Prism Central sits right on top to orchestrate the whole shebang. At the very heart of this exam objective is a powerful feature set inside Prism Central called Intelligent Operations. You might actually remember this by its older names, Prism Pro or maybe Ultimate. Basically, Intelligent Operations is an end-to-end monitoring and planning solution. But for the exam, the absolutely crucial concept you need to grasp is the paradigm shift it creates. It empowers you to proactively detect performance anomalies rather than constantly reacting to user complaints about slow VMs or, firefighting random outages at 2 a.m. You're essentially leveraging machine learning to learn your environment's normal heartbeat. That way, you're alerted the exact second it skips a beat. But hey, here is a massive tip for your study prep. Intelligent Operations comes packed with a ton of features: analysis, discovery, planning, playbooks, reports. But for Objective 14.5, you have to apply a strict exam scope. You need to filter out the noise, focus only on analysis and monitoring. If you're reading study materials or taking practice tests that go deep into capacity planning or automated playbooks, just push them aside for now. Actually, diving into unused features is a really quick way to lose easy points on this specific test. For this objective, we need a laser focus purely on proactive monitoring, and specifically, the Alerts and Events Monitor. Section 2, Alerts and Events Walkthrough. Let's visually break down the core dashboard where all this theory meets the actual Prism Central interface. Now, what's really interesting about this slide is the exact visual layout of that stacked bar chart. You'll find it sitting right below the timeline in the Prism Central Analysis dashboard, and it displays the alerts and events happening at any given point in time. When you're sitting in that exam chair, you really need to be able to visualize this timeline perfectly in your head. See how the data is represented as those vertical bars? In the live interface, if you were to hover your mouse over one of those bars, a tooltip pops right up showing the specific time range, along with a detailed breakdown of exactly what happened during that window. It's incredibly useful because it gives you immediate contextual awareness of your cluster's entire health history. And that brings us to the visual color codes. You're going to want to lock this color mapping firmly into your memory because test makers love quizzing on these specific indicators. A red segment in the bar chart, that depicts a critical alert. It means an actionable situation has been detected that requires your immediate attention. We're talking about a cluster potentially stopping or a node going completely offline. Then you have the yellow segment, which depicts a warning alert. This means user intervention is required, but it's kind of a, hey, fix this before it turns into a critical issue situation. And finally, the gray segment depicts events. These are just occurrences in the system that don't necessarily demand immediate action, but they're absolutely vital for your audit trail and behavioral monitoring. So red is critical, yellow is warning, and gray is event. Lock that in. Once you're actually looking at the Alerts tab, the exam is definitely going to want to know how you can organize all this data. The interface provides a very specific Group By dropdown. There are exactly 3 ways you can group alerts here. First, you can group by entity type. This sorts the list by the specific component affected, like a cluster, node, host, or virtual machine. This one is fantastic for pinpointing something like a noisy neighbor VM. Second, you can group by impact. This categorizes alerts by the severity of their effect on your overall system availability or performance. You'd use this when you're triaging a severe outage and need to prioritize what's actually bringing the whole environment down. And third, you can group by severity, which filters them straight into those critical, warning, or informational buckets. Memorize these 3 options for sure: entity type, impact, severity. Section 3, Anomaly Detection Deep Dive. This is truly the centerpiece of subtopic 14.5, and it's where Nutanix's machine learning really shines.
And this brilliantly illustrates how the Anomaly engine visualizes its findings. What we're looking at is a controller IOPS chart. That's input-output operations per second. See that light blue shaded area stretching across the middle? That is your normal behavior band. Over time, the system has actually learned that this specific entity's IOPS naturally fluctuate within this blue range, all based on historical trends. So, for example, the system learns that IOPS might naturally spike every single morning at 9 a.m. when hundreds of users log into their virtual desktops at the exact same time. That expected 9 a.m. spike is baked right into the blue band. Now, look at that little yellow triangle near the top right. That is a flagged anomaly outlier. The IOPS spiked way outside the predicted expected behavior band. The beauty here is that the system didn't need a static, hard-coded threshold to catch this. It caught it simply because it deviated from its own established normal.
So how does that actually work mechanically? Well, you need to know this exact 3-step mathematical process for the exam. Step 1. The anomaly detection module measures usage every 5 minutes. I'm going to repeat that because it is a prime exam question. It pulls data every 5 minutes. Step 2. It compares that freshly measured usage against the predicted values, basically that normal behavior blue band we just saw. Step 3, if the observed value falls outside that predicted band, it immediately flags that specific value as an anomaly. To give you another concrete example of why this is so powerful, imagine a VM's CPU utilization suddenly pegs at 99%. If this VM runs a massive database batch job every single night at midnight, the engine expects that 99% spike. It keeps it safely inside the normal blue band. But if that exact same 99% spike happens completely out of nowhere at 2 p.m. on a Tuesday afternoon, it fails step 2, the comparison against predicted values, and triggers step 3, instantly flagging it as an anomaly. It is just a continuous, rolling 5-minute cycle of measurement, comparison, and flagging.
Section 4. Common exam traps. Test makers absolutely love edge cases and nuanced default behaviors. So let's make sure you don't get caught off guard here.
All right, here is literally the biggest exam trap you will face on this topic. When you hear the word anomaly, your IT instincts probably start screaming that something is terribly broken. What you might intuitively assume is that an anomaly immediately triggers a red critical alert. But what the exam expects you to know is that by default, an anomaly is merely a behavioral outlier. It's just the system saying, well, that's unusual. It natively records each anomaly simply as an event. It goes straight into that gray event segment we talked about earlier. Let me be clear, an anomaly does not mean automatic critical failure. It just means it's outside the predicted band.
So you're probably wondering, how do we actually make it an alert? This is where the concept of smart alerts comes into play, and they bridge the gap between passive and active. Think about it. A passive event is just that anomaly existing quietly in the background log, but if you want to be actively notified, you have to configure smart alerts. These are custom policies you create to generate a red critical or yellow warning alert precisely when a behavioral anomaly occurs under specific conditions. Why does Nutanix design it to work this way? One phrase, alert fatigue. If every minor behavioral blip sent a critical alarm straight to your phone, you'd eventually just start ignoring the dashboard entirely. Smart alerts let you explicitly configure policies to separate the benign, everyday background noise from actual real emergencies. The key takeaway? You have to actively choose to elevate an anomaly from a gray event to a colored alert.
Section 5. Key facts to memorize. Let's slow down for just a second to ensure you really cement this critical data before test day.
Here is your rapid-fire cheat sheet for Objective 14.5. If you only take away 4 things from this explainer, make it these. 1. The anomaly engine measures usage every 5 minutes. 2. In the dashboard, you can group alerts by entity type, impact, or severity. 3. Memorize those chart colors. Red is critical, yellow is warning, and gray is for events. And 4. Behavioral anomalies default to gray events. They do not become alerts unless you explicitly configure those smart alerts custom policies.
Let's end this with a final, provocative thought to really test your understanding. Imagine this scenario pops up on your exam. A cluster suddenly experiences a massive, unexpected 5-minute IOPS spike, but crucially, it does not violate any static, hard-coded thresholds you've set. Based on everything we just learned about default anomaly behavior versus configured alerts, what color segment on the stacked bar chart is going to record this occurrence by default? Well, if you answered gray because it defaults to an event without a smart alert policy, then you are completely ready for this objective. I really hope this helps you absolutely crush Section 14.5, and I wish you the absolute best of luck on your NCP-MCI 7.5 certification.